Welcome students. In this video I'm gonna teach you how to solve integrals that diverge. I'm gonna present to you why they diverge. So three important integrals. Specifically, I'm going to talk about integrals that involves limits at infinity. So the first important integral that I'm going to present to you is called the harmonic series integral. So the harmonic series integral is the one that says that 1 to infinity of 1 over x diverges. So let's see why that diverges. So from another video I told you that using the limit how to solve this integral using the definition of limits at infinity. The way you would do it is as follows. So the integral from 1 to infinity of 1x dx is equal to the limit as b approaches infinity of 1 over b 1 over x dx. Okay, so that integral is equal to the limit as b approaches infinity of antiderivative of 1 over x, that's ln of x, and I'm going to the limits are gonna be from 1 to infinity. I'm sorry, 1 to b, because we replace b approaches with the limit. Okay, so that's equal to lim as b approaches infinity of ln of b minus ln of 1. All right, so so this part becomes lim as b approaches infinity of ln of b. ln of 1 is 0, so that's minus 0. So you don't write that. And it turns out that the function ln at approaching infinity is equal to infinity. It blows up. Positive infinity. So this tells me that the integral diverges. So that's the first important example that we're going to talk about. The second important example that we're going to talk about is the exponential integral. So it says that we're going to define it as follows. So the is going to be the integral from 0 to infinity of e to the x dx. Again, using the definition of integrals with infinity limits, we're going to write it as follows. Lim as b approaches infinity of 0 to b e to the x dx. So that's equal to lim as b approaches infinity of antiderivative of e to the x is just e to the x going from 0 to b. So that's equal to lim as b approaches infinity of e to the b minus e to the 0. And that's equal to lim as b approaches infinity of e to the b minus e to the 0, that's just 1. And what happens to b approaches infinity of the exponential? It just grows exponential, infinitely exponential. So this blows up. So this whole thing is equal to infinity. Positive infinity. That means that this integral diverges. So that's the second important integral. Now we're going to go to the third important integral. Now this one is we're gonna call it the improper integral of a rational function. And we're going to define it as, the example we're going to give is going to be from 0 to 1 of 1 over x squared dx. Okay, so now we're going to take the antiderivative. So that tells me that I can write it as follows: 0, 1, x to the minus 2 dx. Then we take the antiderivative, that's going to be equal to negative 2 plus 1. That's negative 1. That's going to be negative x minus 1. And then from 0 to 1, and that's going to be equal to negative x 1 over x from 0 to 1. that's equal to negative 1 over 1 minus, this becomes plus because of this minus, over 1 over 0. So that's equal to negative 1 plus 1 over 0. And guess what happened to 1 over 0? That becomes that 1 over 0, this thing becomes so big that the whole integral becomes the whole integral diverges. So this thing becomes infinity. that means that the whole thing will become infinity. And of course this tells me that the integral diverges. So this is the third case. So these three are three of the most important divergent integrals that you and usually textbooks, they combine these functions into similar problems. So you better know these ones, variations of these problems. So thank you, my friends and family and students. Don't forget to subscribe. I really appreciate you for your help.